Welcome students. Today we will continue with the sample size calculation. After that we are going to see very important topic, that is analysis of variance. So today's lecture plan is sample size calculation and one way ANOVA. Determining sample size with estimating mu. We know that the Z formula is x bar minus mu divided by sigma by root n. In this sigma by root n, from this relationship, this n is nothing but your sample size. When you readjust this from these equations like z sigma by root n x bar minus mu, right, then root 10 you can say z sigma divided by x bar minus mu, that will be your root n. You square both side, so z square sigma square divided by x bar minus mu whole square, that will be your n. So that is nothing but this one. So the numerator, this x bar minus mu, we are going to call it as error of estimation, otherwise tolerable error. So sample size is, when you readjust it, see that z square sigma square, this is sigma square divided by error square. Okay. Since the everywhere square is there, we can bring it to common. So many time the value of population standard deviation may not be known, so there is approximation. The 1/4 of the range of the data which you have collected can be taken as standard deviation. We will do an example calculating the sample size. So the permissible error is given 1. The population standard deviation is 4. You want to conduct 90% confidence level. If it is 90% confidence level, the Z value is 1.645. Then you substitute here, you will get 43.30, nothing, then that is equivalent to 44. We will do another problem to find out the sample size. So permissible error is 2, range is given 25. 95% confidence level, Z equal to 1.96, this value which you have to get from the table. So estimated sigma is 1/4 of the range, so it is 6.25, then substitute Z square sigma square divided by E square, you are getting 38. Now we will see how to find the sample size when estimating the population proportion. If you are estimating the population proportion, the formula for Z is different, p hat minus capital P root of capital P and capital Q by n. This p hat is the sample proportion, capital P is the population proportion. So the error is p minus capital P. The same way what we have done previously, if you for example, when you bring this in z root of p q divided by n equal to p hat minus p, you square both side, z square p q by n equal to p hat minus p whole square. So this will become z square p q divided by p hat minus p whole square, that is nothing but your n. So this p hat minus p, you can call it as E, so that is E square. So n equal to z square p q divided by E square. We will do one problem here. So the permissible error is given for 98% confidence level, the z value is 2.33, which you have to get it from the table. Estimated p is given, population p is given 0.40, so q is 0.60. When you substitute this value, it will be 1448. You see that whenever you go for population testing, population proportion, generally you may have asked yes or no type. That time obviously you have to go for more number of samples. Sometime what will happen, the value of p which were given 0.4 may not be known to you. Okay. That time how to decide the sample size? Determining the sample size when estimating p with no prior informations. You see there, look at this, the p is in the x axis, sample size in the y axis, Suppose the value of p equal to 0.5, the maximum sample size is required. So, what is the logic, what we have to understand from here is, if we are not knowing the population proportion, we have to assume equal to 0 equal to 0.5. Even if the value of p goes above 0.5, see that the n value is decreasing. The value of p goes below 0.5, that time also the value of n is decreasing. It is better to assume p equal to 0.5, so that you will get maximum number of sample size. In this situation, say error is given 90% confidence level, z equal to 1.645, with no prior estimate of p, we have to use p equal to 0.5. So, if you p equal to 0.5, q equal to 0.5, you substitute, you go for 271. So, if the population proportion is not known to you, you have to take p value equal to 0.5. Next we will go to next topic is ANOVA. Why ANOVA is required? So far we have seen 2 sample Z test, 2 sample T test. Whenever there is a requirement for comparing more than 2 population. So far what we have done? First we have done 1 population, next we have compared 2 population. If you want to compare more than 2 population, you should go for ANOVA. There is a possibility you can compare 1 and 2, suppose this is 1, this is 2, this is 3, you can compare 1 and 2, 2 and 3 and 1 and 3, 1 and 3, there are 3 comparison, but we will not go for that one because there is a reason for that, I will tell you. We could compare the means one by one using t-test of difference of means, because what will happen, each test contain type 1 error. So, the total type 1 error is 1 minus alpha power k, where k is number of means. For example, if there are 5 means, if you use alpha equal to 0.05, because 5C2, you must make 10 2 by 2 comparison, because every comparison your confidence level is 0.95. If you are making 10 comparison, the overall confidence level is 0.95 power 10. So, 1 minus confidence level is nothing but our error. So, 0.95 power 10, that if you subtract from 1, that is nothing but your error. Error is 40%. That is 40% of the time you will reject null hypothesis of equal means in favor of alternative. That is why we should not go for 2 sample t-test. Whenever if you want to compare more than 2 population, you should go for ANOVA. Here hypothesis testing with the categorical data, because we are going to say group 1, group 2, group 3. You see, we have seen 2 sample Z proportion test. You remember 2 sample Z proportion test. If you want to go for comparing more than 3 population proportion, if you want to compare the proportion of more than 2 population, you should go for chi-square test. Similarly, if you want to compare more than 3 population mean, you should go for ANOVA. So, chi-square test can be viewed as the generalization of Z test of proportion. The same way, the ANOVA can be viewed as the generalization of T test, a comparison of difference of mean across more than 2 groups. Like chi-square, if there are only 2 groups, the two analysis will produce identical result. Thus, a t-test and ANOVA can be used with the 2 groups. If there are 2 groups, you can go for ANOVA and t-test, both will give you the same answer. Why this concept of ANOVA is more important? Suppose in the production process, say there are different input variables, x1, x2 and xp. So, these are controllable inputs. There may be some uncontrollable inputs, that is z1, z2, z3. So, the input may be raw materials, component and sub-assemblies. So, the output is the quality characteristics. What will happen? This quality characteristics y is generally affected by this x1, x2 and x3, right. See, that is output product. So, if it is affecting y, we need to find out what combination of x1 and x2 will provide better Y value. So, measurement, evaluation, monitoring and controlling. For that purpose this ANOVA is required. So, purpose of ANOVA is if there are many input variables, how this input variable is affecting the quality characteristics. For that we can find out with the help of ANOVA. See, when we want to improve the quality, see application of quality engineering techniques and systematic reduction of process variability, because when we want to improve the quality is nothing but reduction of the variance. So, when you go for acceptance sampling, there will be lot of variance, because the acceptance sampling is, suppose we go for, say they calls n comma c. So, if I say 10 comma 2, this is n is the lot size, c is the acceptance number. So, what is the meaning of this n comma c is, if the lot size is 10, I will count all the defective products. If the number of defective is 2 or less, I will accept the whole lot. If the number of defective is 2 or more, I will reject the whole lot. So, there is it is a kind of a intuitive process, there is a mathematics behind it which follow binomial distribution, but it is a very easy way, but there is a there are more variability still will be maintained. When you go for statistical process control, when the process started, then if you are controlling the process parameters, then you should go for statistical process controls like our control charts. But the design of experiment is before starting of the experiment, before manufacturing, at laboratory level you can see what are the parameters that will affect the quality of the product. So, we can control that product, so that you can control that variable, so that you can improve the quality. So, with the help of design of experiments we can maintain high level of quality. That is why people are interested in design of experiments. The base for this design of experiment is nothing but your ANOVA, analysis of variance. That is why I am trying to connect the connection between the design of experiments and ANOVA. I am going to explain the concept of analysis of variance with the help of an example. The example is, there are 3 teaching methodology. One way of teaching is with the help of blackboard, another way is with help of case studies, third way is PowerPoint presentations. Suppose I want to know which teaching methodology is more effective, or is there any difference, is there any influence of teaching methodology on student performance. So, totally 9 students was taken, in each group 3 students are allotted randomly. So, what you see here is the marks obtained by the students when they are asked to study in blackboard group, when they are asked to study case presentation group, when they are asked to study in where the teacher is using only PowerPoint presentations. So, whatever value which you are saying, whatever value you are seeing, this is the marks, these are the marks. Okay. So, what is the null hypothesis here? The null hypothesis is, I am going to assume that null hypothesis is H naught mu 1 equal to mu 2 equal to mu 3. Alternative hypothesis is mu 1 not equal to mu 2 not equal to mu 3. If you see, even this technique name is called ANOVA, analysis of variance, but I am comparing mean. So, what I am going to do here, with the help of the concept called variance, I am going to compare mean of 3 populations. Okay. Nothing to do, I am not comparing the variance, I am comparing the mean of 3 populations. So, for the group 1, I have taken the sample mean, that is 3. For group 2, I have taken sample mean, it is a 4. For group 3, it is 2. Then I find the overall the sample mean 4 plus 3 plus 2 plus 2 plus 4 plus 6 plus 2 plus 1 plus 3 divided by, there are 9 elements, it is equal to 3. What I am going to do? I am going to find out the overall variance, that I am going to call it as SST, total sum of square. Here why I am saying it is a variance, see the variance formula, we know that the variance, what is the formula? Variance equal to sigma of x minus x bar whole square divided by n minus 1. This numerator, that is sigma of x minus x bar whole square, that I am going to say sum of square. So, I am going to find out the overall variance, that overall variance, that is SST, I am going to group into two categories. One is variance due to treatment plus variance due to error, that is error sum of square. So, what I am writing SST equal to total sum of square equal to, sometime they write B between columns, SSB plus SSE, this E, SSE. So, obviously if the variance due to treatment, that is B, SSB is dominating, we can say that the teaching methodology is influencing variable. First I will find out the overall variance. For that variance I am going to find out only numerator. So, that I am going to call it as SST. What is SST? How each element is away from overall mean. Overall mean is 3. So, in the first column the first element is 4. So, 4 minus 3 whole square, value in the second column is 3, 3 minus 3 whole square plus 2 minus 3 whole square up to this, it is 18. So, this 18 is nothing but total sum of square. This 18 I am going to see how much variance is due to this teaching methodology. So, I am going to call it as SSB, some books call it as SS treatment, that is treatment sum of square. So, what is the treatment sum of square? In the first column there are 3 elements is there, 3 minus the first column mean is 3. So, this 3, the overall mean is 3. So, 3 into 3 minus 3 whole square plus the second column. So, this 3 represents the number of samples in each column. This 3 represents, in the second column there are 3 elements. So, this 4 represents the mean of the second column is 4 minus this 3 is overall mean 3 whole square plus for third column also there are 3 elements. The mean of the third column is 2. So, 2 minus this 3 is overall mean whole square. So, this will become 0, 4 minus 1, 1 square into 3, 3, 2 minus 1, 1 square and 3 equal to 6. So, the 6 is numerator of that variance, that is SSB is 6. Then I will find out SSE, that is a variance error sum of square, that is inherent variance. For inherent variance, when you look at the column 1, the first element is 4, the mean of the first column is 3. So, 4 minus 3 whole square plus the second element is 3 minus the mean of the first column is, so this 3, this say mean of our first column. So, 4 minus 3 whole square plus 3 minus 3 whole square plus 2 minus 3 whole square. So, this 4 represents mean of the second column and this represents 2 represents the first element in the second column. So, 2 minus 4 whole square plus 4 minus 4 whole square plus 6 minus 4 whole square. The third one is this 2 represents mean of the third column. This 2 represents the first element in the third column. So, 2 minus 2 whole square plus 1 minus 2 whole square plus 3 minus 2 whole square. When you simplify that, it is 12. So, what happened? The SST is divided into two categories. One is variance due to treatment, this is error variance or individual variance. The second one is we have to find out the degrees of freedom. Okay. For SST, what is the degrees of freedom? There are 9 elements. So, 9 minus 1, that is your degrees of freedom is 8. For SSB, there are 3 columns is there. So, 3 treatment. So, 3 minus 1. So, that is 3 minus 1, 2 is the degrees of freedom. For SSE, see in the first column there are 3 elements. So, the first column will have 2 degrees of freedom. In the second column there are 3 elements. So, 3 minus 1, 2 degrees of freedom. The third column also there are 3 elements. So, 3 minus 1, 2 degrees of freedom. So, totally 6 degrees of freedom. After that, we have to find out F value. F is nothing but MSB divided by MSE. That means, what is MSB is mean square between columns. This is means error square. So, what does this mean means? If you divide this SSB divided by corresponding degrees of freedom, you will get MSB. When you divide SSE divided by corresponding degrees of freedom, you will get MSE. If you look at the previous one, SSB is 2, degrees of freedom is 2. So, 6 divided by 2, SSE is how much SSE, that is 12, degrees of freedom is 6. So, 3 by 2, it is 1.5. So, that 1.5 is nothing but this 1.5. Okay. So, next what you have to do, this is we can say your calculated value, you have to refer your F table. In F table, assume that alpha equal to 5%, you have to look at the what is this value. For example, you look at the table, it will give you 5.14, but your calculated value 1.5 is lying on the acceptance side. So, this is F table. So, you have to accept null hypothesis. This is an simple intuition for how this concept of ANOVA is working. In the next class, we will do more theory behind this ANOVA, we will continue. Okay students, in this class we have seen how to find out the sample size for hypothesis testing. Then I have started the concept of ANOVA. For ANOVA, I have taken one example, then I have explained what is the SST, that is the total sum of square, treatment sum of square, error sum of square. Then I have explained when should we go for ANOVA. Then I have solved one problem. Then I have compared calculated F value with table F value. Then I have concluded the conclusion also. The next class, the same problem we will solve with the help of Python. Then we will continue. Then we will go for post-calc analysis. Post-calc analysis is whenever you reject null hypothesis, we have to say which two pairs are different. So, that we will see in the next class. Thank you very much.